Your app works perfectly with 100 users. Then your user base starts growing, and hundreds become thousands. Thousands become hundreds of thousands. Suddenly, one server just isn't enough anymore, and the solution isn't buying one giant expensive server. It's running multiple servers and using one component to decide where every incoming request should go. That component is called a load balancer, and here's exactly how it works. Say you have three identical copies of your app running. We'll call them Server A, Server B, and Server C. Without a load balancer, every user connects directly to one server, which means if that one server goes down, everyone goes down with it. A load balancer sits in front of all three. Every request hits the load balancer first, and the load balancer decides which server actually handles it. But how does it decide? The simplest method is called round robin. The first request goes to A, second goes to B, third goes to C, fourth goes back to A. It just cycles through the list over and over, no thinking involved. Say you're getting 9 requests per second, each server gets exactly 3, clean, even split. That works great as long as every request costs about the same amount of work. But the moment they don't, round robin falls apart. Here's why. Say request 1 is a user loading a tiny profile page takes 10 milliseconds, but request 4 is someone exporting a massive CSV report. That ties up server A for a full 8 seconds. Round Robin doesn't know that. It keeps sending every third request to A anyway. So, while A is stuck grinding through that export, 3 more requests pile up behind it. Users start seeing timeouts. Meanwhile, B and C are basically sitting idle. The load balancers split traffic evenly, but even isn't the same thing as fair. So, a smarter approach is called least connections. Instead of blindly cycling, the load balancer keeps a live count of how many open connections each server is handling right now. Say A has 6 open connections, B has 2, C has 3. A new request comes in, it goes straight to B because B has the fewest. Another request comes in. B now has 3, same as C, goes to either one. Meanwhile, A is still chewing through that export. The load balancer sees 6 connections and just keeps routing around it automatically until A clears up. Nobody told it that exports are expensive. It figured that out just by watching the numbers. Now, here's the part that makes load balancers matter beyond just speed. It's 2 in the morning. Server C runs out of memory and crashes. No warning, no graceful shutdown, just gone. If the load balancer doesn't know C is dead, it keeps routing requests there, and every one of those users gets an error. So load balancers run health checks. Every few seconds, they send each server a tiny ping, basically asking, "Are you alive?" A responds, "Healthy." B responds, "Healthy." C doesn't respond. The load balancer waits, tries again. Still nothing. It marks C as down, pulls it out of the rotation entirely, and all traffic splits between A and B. From the outside, nothing changed. A user hitting your site the exact second C crash doesn't notice a thing. Their request quietly lands on A or B, and the response comes back just as fast as always. 20 minutes later, your team reboots C. It comes back online, the health check pings it. C responds, and the load balancer quietly adds it back into rotation. No restart, no deploy, nobody had to touch anything. This is called failover, and it's the real reason you want a load balancer, not just for traffic. So the whole system comes down to 3 things: multiple copies of your app doing the actual work, a routing algorithm round robin, or least connections deciding who gets each request, and a constant background heartbeat of health checks ready to pull a dead server out before any user notices it's gone. One server crashing used to mean your whole app was down. Now it just means one server's taking a short break. If this changed how you think about scaling, subscribe. There's a lot more to how these systems stay alive under real traffic. And if you want a complete guide document on load balancers, drop a comment below.